Welcome to part 3 of the saving and loading tutorial. I believe this will probably be the last part, because I think we're getting close to the end here. But there are a few more things we need to do, because as you can see, we can't actually save the game ourselves yet, and nothing's actually getting saved, like the position or anything like that. So that's what we'll be doing in this final video. So the first thing we're going to need to do is come back over here to C++, and we're going to want to create a save interface. And this is going to be a really powerful tool that will allow designers or anybody working on your game to easily save stuff. All they'll have to do, for the most part, is implement this save interface, and it will give them the tools that they need to save something really easily. So to do that, actually we do need to come back here and right click and say new C++ class, and all the way at the bottom there's an Unreal interface, and that is what we want to create. So click on that, hit next, and we will name it save interface and hit create. And wait for Unreal. Okay, so in the save interface we want to have two functions, and basically anybody that implements this interface will have to define these functions. Well, I guess they'll only have to define one of them. The other one is kind of optional, so I'll show you here what I mean. So one of the functions, the one that they have to define, is going to return an F string, and it's going to be get unique save name. And I'll explain what this does in a second, but first it's a U function, and we want to say it's a blueprint native event, because it needs to be a native event so that blueprints can implement it if they want to, but also somebody in C++ could implement it if they want to, and that's what the native event allows for. And we say category save interface is probably good. Alright, so what this function is going to do is it's going to expect you, who's ever implementing this interface, to return a unique name, a unique save name that will be used when it's saving information about your object. So for the player, you would say, player or something. If you had like an enemy manager, you would call it enemy manager. But it's basically just going to be a unique name that when you're saving stuff, it will use, and so it knows which object it's saving stuff for and which object it's loading stuff for. It's probably a lot less confusing than I'm making it sound. So all this is going to do is get a unique name to use when saving. And the other function is going to be called on before save. And this is just an event that will get called, and you can do stuff in it if you want, or you can not do anything in it if you don't need to. And I'll show you why this is sometimes useful once we get to actually saving stuff. But for now, just know that it's going to get called right before the saving happens, so that the actors will have a chance to, if you want to save your location, you'll have a chance to grab the location and save it before it serializes your class. So called right before the owning actor is saved. Now, since this is an interface, we don't actually need to define these functions, because the people that are implementing the interface are going to define these functions. The other thing we need to do, the last thing we need to do, I think, in C++ is finish filling out this save game data and the save manager. So currently the save game data is empty, but what this save game data is supposed to be for is it's going to save all the information about your game itself. So anything from the player's health to the current time of day to, what level you are, to information about enemies, just everything about your game that you could ever want to store is going to get stored inside of this save game data. It's basically a slot, right? So inside of here, we need to make a couple things, really not that much actually. Let me go look at my notes. Save game data. Okay. So inside here, we're going to want to make a map. And the map is going to map the unique name of the object to its save data. So there'll be one for the player, one for any enemy you might have, and so on. And we will put that here in the public section, and it will be a U property. And we'll say visible. I always spell this wrong. Visible anywhere. And like I said, it's a map of f string. And again, the f string is the unique name to something that we need to make here in a second called f save data, which is just a struct. And we're going to call this serialized data, and that will make more sense in a second. So right above this class, we're just going to make a very small struct that just has one thing in it. So we'll say struct and struct f save data. And we need to add this generated body, so I'm just going to copy that. And then here we want to have one U property. It's also going to be visible anywhere, so I'm just going to copy that as well. And we want to say, or we want to basically have a T array of uint8, and it's called data. And you're probably going, well, what the heck? Why? So basically what's going to happen is whenever you want to save something about a character, say you want to save the player's health and you want to save his energy and you want to save his currently equipped gun, right? All that information is going to get serialized into a buffer, which is this, which is just an array of characters, which is what this is. It gets binarized, basically. And so all that crazy information that you want to save is just going to end up in this array of data. And Unreal will essentially take care of putting it in and taking it out for you, which is the confusing part. We just need a place to store it. So that's what this is. So I know this might look a little confusing, but really all this is just, you just have a map which maps the name, the unique name of the thing that's saving, so the player maybe, to its data. You might have an entry for an enemy manager, you might have it for a car in your game. Anything that needs saved will have an entry in this map to its save data. So hopefully that makes sense. Okay, so we need to come back to the save manager and finish filling out these to-dos. So we have three. We have one for query all interfaces. We have one in the load game, and we have one, oh, I missed it. We have one in the save game. So we'll do the query all save interfaces first, because I believe we can do that now. So let me go back to my notes for reference. Okay. So the first thing we want to do is we need to add something to this class. The save manager class needs to hold on to all of the objects or all the actors in the game that implement the save interface class and want to be saved. And this will make a lot more sense once I show you an example here at the end of the video. But for now, just go to the save manager and oh, sorry, I got confused. Yeah, go to the save manager, and in here at the top, we want to make a static array, so static T array, and we want it to be an array of interfaces. So we need to include our interface that we made, so save interface. And it's an array of I save interface. We'll call it save interfaces. And all this is an array of all the actors in the game which implement the save interface. And if they implement the save interface, that means there's something about the actor that wants to be saved, regardless of what it is. Now there's a little tricky thing. If you want to make an array of save interfaces, you actually need to add one thing in front of it. It needs to be an array of T script interface, and then in there you put the iSave interface. It's a little weird syntax thing, but that's the way you do it. All right, so just like the current save slot, since it's a static variable, we're going to copy this, go to the save manager, and at the top, we need to do what we did for this one. So get rid of static, and then scope it in, and that way we won't get that compiler error that we got last time. Okay, so now that we have that, we can start writing this function. So the first thing we want to do is we actually want to clear this. And the reason we want to do that is because if you're running it through the editor, every time you run the game, you want to make sure that you clear this so that if you added more actors to the level between runs, that they would get added to the list if they need to be. So all we're doing is, clearing the old entries, right? And then after that, we want to get all the actors that implement the save interface. And to do that, there's a handy function for it called uGameplayStatics, get all actors with interface. And for the world, we can just say g world. And the interface that we're looking for is the uSave game interface. Why is it not showing up? Oh, it's just uSave interface, right? : static class. And it wants an out array of actors, so we need to make one of those real quick. So we'll make a T array of actor pointers called actors, and we'll pass that in to get filled out. So once that's filled out, we'll just loop over them. So for actor pointer actor in actors, we want to add it to our save interface. So save interface dot add actor. So again, all we're really doing here is getting all the actors in the world or in our level that implement the save interface so that we can store them so that when it comes time to save or to load, we'll be able to call the appropriate functions. And that's all we need to do there. So now in the save game, I said earlier we were going to do, eventually we were going to go over all the actors that need to be saved and save them. So now we actually have those actors. So we'll remove this to do, and we'll actually to do it. So we're going to make a for loop, and we basically want to go over all the save interfaces. I'm just going to use auto for save interface in save interfaces. We want to check, we just want to be sure that the object that implements the interface is not null, and to do that, you can just say save interface dot get object, and we want to say if save interface dot object equals null. We want to continue because we don't want to do anything with that guy. But assuming it's not null, which most of the time it won't be, we will first let the object know that it's about to be saved. And to do that, we'll just call this function that we created. Where is it? Where's our interface? Save interface. So yeah, that's why we made this on before save. That's the function we're going to call. And it will make more sense why that's useful later, but that's what we're doing right here. So we're going to let the object know that it's about to be saved. So to call an interface function, I really spelled that wrong. Save interface. So to call an interface function, off the interface, you actually have to say, and it doesn't show up in this list sometimes, but you have to say execute and then the name. So execute underscore on before save. And all it wants you to pass is the object to execute it on. And we have that, which is the save interface get object, like so. So all that's doing is it's calling the on before save function on this object. And this object is whatever object is implementing that interface. So like the player, for example. So we've let the object know that it's about to be saved so it can do anything that it needs to do. The next thing we need to do is we need to get that unique name from this function. Get unique save name. We need to get that unique save name so we know which data we need, like which data is associated with it. So find the object's save data using its unique name. So we'll get its unique name. So f string unique unique save name equals, and just like we did with this interface function, we're going to do below for the other one. So save interface, and we need execute get unique save name, and it wants the save interface get object. And again, don't worry about these red squiggly lines. It's just Unreal being dumb. So we have the unique save name, and from there we can look it up. We can look up in the serialized data, or in the, sorry, we can look up in the save game data. So in the save game data, remember we have this map of strings, which is the unique name to the save game data. So we can look up that object's save game data in this map. So to do that, we just say save game data, which is just from right up here where we created it before. And we want to get the serialized data from it. And we want to say find or add, which really we're just, I guess we're probably always going to be adding it because we're creating a brand new save. So maybe we should just say add, right? So we're adding new data, and the data we want to add is to the unique save name. So we can catch a reference to that data. So f save data by reference equals that. So now we have a reference to that data that we want to save to. And here is the part where Unreal will do most of the heavy work for us. We basically just want to serialize that object. And to do that, we need to create something called a f memory writer, because we're writing to it, because we're saving. We'll call it memory writer, and we'll make f memory writer. And what this takes in is exactly what we have inside of our save data. So inside of here we have a t-array of uint8, which is again just a big buffer of data. And that's exactly what this wants. So save data dot data. And there's one thing we need to set on this. We need to tell it that we are saving and not loading. And to do that, we just say memory writer. Man, where did my IntelliSense go? I don't have any IntelliSense. How am I supposed to do this? And there's a variable called ar is save game, and we want to set that to true. And that's just saying, hey, we're using this memory writer to save. And then once we have that, we just have to call the magical serialize function off of our save interface, or off of our object, sorry. So we need to get our object. So it's in our save interface, get object. So again, this is just like our player or something like that. And we want to say serialize. And we give it the memory writer. I'm going to do a quick compile here to try to get my IntelliSense back. Sometimes that fixes it. But yeah, just to recap. So we'll do a recap after we get it working here. Save interface. See, this is why I don't like coding without IntelliSense, because I can't see when I mess up. Recompile, come back. Just make sure this compiles real quick. Oh my gosh. Such a failure. Get object is not a member of iSave interface. Pretty sure it is. Oh, it's because I need a dot, not an arrow. Try it again. All right. That thingy means we did it. So just to go over that again, because I know that was probably a little confusing. We go over all the actors in the game that implement the save interface, meaning they want to be saved. We make sure that the object exists and is not null. We let the object know that, hey, we're about to save all of your information. And then we get the object's unique name, and we, in our save game data that we just created, we add a new entry for that new object. And then we serialize that data. And Unreal basically takes care of the rest. So now all of that data about that object is saved into, man, my IntelliSense is really, I'm going to restart real quick. I'll probably edit this out. All right, well, I kind of got IntelliSense back, so I'll continue right where I left off. So now that we have everything serialized for that object, we are good to go. So now we can come down and write the load code. So right here I have a to-do where we're going to loop over all the actors and load their data. So we can actually do that now. So we'll get rid of this to-do, and we will make another for loop. So we're looping over each save interface in the save interfaces. And again, we want to check and make sure that the save interface's object is not null. So if it is null pointer, we will just continue. And the next thing we need to do is, again, we need to find this object's unique name and save data. So we can basically copy kind of what we did above, where we find the object save data using its unique name. Yeah, we just basically want all of this. So we'll copy that. Now we don't want to add our unique save name anymore. We just want to find it because we're loading. We don't want to be adding any new information. We want to try to find it. And since that's the case, it's going to return to us a save data pointer. And if for some reason the save data pointer is null, which I don't think it ever should be, we will continue. But in most cases, we can then essentially deserialize the data for the object. So deserialize the object's save data. And to do that, it's very similar. Before we created a memory writer, this time we want to create a memory reader called memory reader. And we want to give it, once again, the save data, which is just that array of unsigned integers for our buffer. And we want to tell it that we are not saving, so we'll say memory reader dot AR is saving, or is save game. I want to set that to false since we're loading. And then we can finally say, once again, save interface, get object, and serialize the memory reader. And what that will do is it will take all that data that we serialized in the save, and it will deserialize it and reset all the variables that need set. So essentially it will load the object. And just like that, I think that might be all we need to do. Let's go give this a quick compile. Oh, I closed it when I was fixing, so compile or launch it, whatever you need to do. I need to relaunch it again. But I think that might be it. I think that's all the saving and loading code, other than showing you some examples now of how to use it, assuming it actually works. So let me just make sure we're still in a good state here. So go back to our other map, main menu. So we launch this. We got our save slot 1, we load save slot 1. New game, we got save slot 2. Okay, so it looks like that's all good. So the first thing we want to do is delete these existing slots. So just kill them all, and then close it, because they were no good, or they're going to soon be no good once we start actually saving stuff. So let's actually save something now. We can finally get to the fun part. And this is the part that would hopefully make it all worth it, because I think you'll see how easy it is to do this. So say, for example, you want to save the character's position. So go to your blueprint, open this up, and if we want to save anything about this character, or any actor for that matter, we need to implement the save interface. So go to class settings, and then over here on the right, just hit add and say save interface. And you can see, if you notice on the left, it automatically created this get unique save name function that it wants us to fill out. So we need to type a unique name here. And we just need to make sure that this name is not being used by any other object that's being saved in our level. And as long as it's not, then we're good to go. Okay, so the other thing that that interface gave us is it gave us the on before saved event. So if you just right click and you type it in, you can see you can create that event if you want to. You don't have to, but for the player's location, we're going to need it, and you'll see why here in a second. So right before the game gets saved, we want to get where the player's location's at, and we want to save that. So we want to say get actor location. Now we want to save this value. And all you have to do, since we're using the serialization stuff, is create a variable, say player location, and it's a vector. And we set that. And you want to come over to the player location, and you want to check, drop down this expanded window and check the save game checkbox. And that is all you need to do for any variable in your whole game, no matter what actor you're in. As long as it implements the save game interface, and this variable's and this checkbox is checked, then that variable will get saved. Now, if it's a variable like location, where you need to actually set it right before you save, then you'll wanna do that in the event on before saved. But some things like health that are continuously being updated, you wouldn't actually have to do that. You would just check this checkbox and you'd be good. So that's saving. Now for loading, that's also super easy. So to load the player's location, all you want to do is in the begin play, you want to simply set it. So it might seem weird, but in the begin play, you're going to get the player's location because it's going to have been loaded by now. And you want to say set actor location. And probably teleport, since we are just starting there. So yeah, this is literally all you need to do to save the player's location. If you had other stuff you wanted to save, depending on exactly what it is, sometimes you need to do it in here, but pretty much all the time in begin play, you want to, if you had a health, you would, set your health right here to whatever the variable is. It might be a good idea to add these to a category like, saved variables or something, just so you know which ones are being saved. But that's the general gist. So if I go ahead and run this, hopefully this just works here, first try. So we'll do a new game, and we'll come over here, and, oh, I didn't actually write the button to save it. That's really easy. So I'll leave it up to you guys how exactly you want to handle saving game. I know some games like to save at checkpoints, some games like to allow the player to save it through the pause menu, but however you decide to do it, it's super easy. Just type save game off of whatever you want. I'm just going to make a quick little input P or something. So when they press P, it will save the game. But again, all you have to do is just call save game from wherever you want, and it will just magically work. So new game. Come over here, press P. I'm going to wait for those little, okay. Press P, you can see it says save to save slot 1. And look, I'm standing right here in the middle. And if I go and I load, save slot 1, boom, I am right here back in the middle. Now, one thing to note is I am just saving the location. I'm not saving the entire transform, so it's not going to save rotation as well, but you could very easily do that. And I just wanted to show you like one more example just to show you how easy and cool this is. So that little ball that I created back in the beginning that changes colors, I'm just going to recreate that. If you don't care to see this, you can end the tutorial now because I'm not going to be doing anything else for the actual system. I'm just doing an example of how you might use it. But it is kind of cool. So I'll call it color changer, and we'll just create a quick little blueprint called BP color changer. And then the other thing we're going to need for it is just a little material. So we'll create this and say m color changer. And in here, we just want to make a vector or constant 3 vector and hook that up to the color. And if we right click, we can convert it to a parameter so we can change it. And we'll call it the color. And we'll just hit apply and save. And we can close that. And then in our color changer, we want a static mesh. And I just want it to be a sphere. So we'll say shape sphere. And we're going to add a dynamic material to it so we can change it at runtime. So to do that, I'll come into the begin play. And we want to create dynamic material instance. And we can get rid of these. And the parent is our m underscore color changer that we just created. And we're going to promote this to a variable because we're going to need access to it. And it will be called our material instance. And I think that's all we need to do there. And then the other thing we need to do is make it so when you walk into it, it will change colors. So real quick, we need to change the collision on this to be overlap all. And then we can add the component begin overlap. And inside here, we need to get basically a random color. So we want to do rand range or rand float, random float in range. We want from 0 to 1, and we want 3 of these for the red, green, and the blue. And we're going to say material instance set vector parameter, and the parameter name is color. And we will make this wants a linear color, so we will make linear color red, green, blue, and alpha. And we'll set that up like so and drag that in. All right, so if we're not doing any saving and loading for the color of the ball, this is probably what it would look like. I think I have everything correct here. Let me just run it. Oh, I need to actually add it to the world. So go back to 30% CPP maps, and we'll just drag one of these guys into the world. Oh, I already added one in my earlier video when I canceled it out, but just drag one of these into the world. And if we go ahead and run this, it should be, why is it not black here? Set it to 0 to 1. Oh, we're not actually, so we need to actually set the material. So set material, like so, to our material instance. And now it should show as black. Okay. And then when we walk over it, it changes to a random color. That's weird. It shows like the same color 3 times. Okay, so as you can see, if I run this again, it just goes back to black, even if I press save, because we're not actually saving anything about the color of the ball. So just to show you like how super easy this is, now that you have all this infrastructure behind it, all you would need to do is just save this color. So right click on this and promote to a variable and hook this up. Hook that up, and we'll just say that this is the current color, and you want to set this as save game so that it gets saved. And then you just need to implement the save interface, since this actor is now saving stuff. And for the unique save name, we'll just say color changer. And so now this color is actually going to get saved for you, and that's all you needed to do. If you want to load it, you can do that in the begin play by simply doing this in begin play. So I'll just copy this again, and right after we create the material, we'll just set the color to whatever this is. And again, this is going to get loaded for us behind the scenes. Oh, it needs the material instance. So now when we go ahead and run this, we will give it some purple color, press save, run it again, and you can see it saved. And literally in like less than a minute, I was able to save the color of this ball that I created. So you can use this for like anything. It's super powerful. If you actually went through and set it up like this, it's going to save you so much trouble down the road, because like I said, a lot of the other tutorials I saw, you know, they showed you how to save and load something, but they really didn't show you how to create a system for it that worked well and that allowed other people to easily do it for you. And this is just a really great way to do it. But anyways, that's going to wrap it up. If you enjoyed the video, I'd really appreciate a thumbs up. I spent a lot of time figuring out how to do this and putting this together, so I know it was really long, and I appreciate anybody who hung out through the whole thing, and hopefully this helped you out. So drop a like and a subscribe if you liked it, and I'll see you in the next video.